Hi guys. Okay, so in this video, we are looking at the homework questions from chapter 11, acids and bases. And these homework questions are 7, 9, 11, and 13 from the Timberlake book. That is the Structures for Life's General Organic and Biological Chemistry. Okay, so here we are going to look at the questions that relate to Bronsted Lowry acids and bases and how to identify the conjugate acids and base pairs. Okay, so your question number 7 here, you are given identify the Bronsted Lowry acid and a Bronsted Lowry base. In other words, they are simply asking you which one is an acid and which one is a base. So here, remember, every acid has a conjugate base, and every base has a conjugate acid. Okay, so okay, so the first question is relating to like in the reactants. So in the reactant, so basically we are going to looking at the HI and water. So which one is acting as an acid and which one is a base? Okay, remember, Bronsted Lowry acid is something that will release hydrogen ions, and later they form the hydroxyl ions. And then the base is something that is going to release the OH ions. But it's not just all the time OH ions. Those OH ions, if something can give electrons and those OH ions can be in situ, can be made, then that can also act as a base. So here we have HI. HI is going to, I'll show you, HI aqueous, when this releases, so Arrhenius said that this is going to give you a hydrogen ion and the iodide ion. So this is the Arrhenius theory, Arrhenius theory. Okay, Arrhenius was talking only about the hydrogen ions, which is valid, it's important. But Bronsted Lowry went a little bit further. Bronsted Lowry, he said that for the acids. So for the acids, they said that, let's look at this, water, oxygen and water, and this is called these two lone pairs. And here you have the HI. Now here what's happening, the lone pairs. So remember that this is a polar bond. So hydrogen is delta positive. Iodine will have a delta negative charge. Oxygen has its lone pair, so it gives its lone pairs to hydrogen, and this bond breaks or the iodine is released. So what do we have here now? We have H, O, H. This will remain intact, but positive charge comes on oxygen, and you have a new bond, which is not like it's a very weak bond. Okay, coordinate covalent bond, and you will see the iodide ion or any of the polyatomic ions, any of the non-metals, they are going to be liberated like this, and you're going to have the H3O plus, which is the hydronium ion. So out of this, out of HI, when you're comparing basically HI versus H2O. So which one is acid and which one is base? That's the question is being asked. So we see that HI is acting as an acid because it is able to release the hydronium ion, or it's able to release the hydrogen ions, which are acidic in nature. Okay, so that's one piece. Next is, what about water? What's the deal with water? So here we see, let me use a different color, hydrogen with water. So when water is acting as an acid. So here, water is acting as a base. So because here the water, this is an acid, and water is acting as a base. Why is water acting as a base? Because water is giving electrons. So anything that gives electrons acts as a base, and anything that takes electrons or accepts electrons acts as the acid. Okay, so in this case, the conclusion is that HI is the Bronsted Lowry acid. Bronsted Lowry acid. And let me put this here, BL acid or B acid. BL acid and H2O. Although water is always neutral, but H2O is acting as a Bronsted Lowry base. Okay. Next is the H2S versus CH3, CH2, NH2. What about that? So H2S. So here again, see, all the time acids will have the hydrogen in front. So even though H2S is not directly acting as a direct acid, but it has the acidic properties because it can release these hydrogen ions. So this thing. So once the hydrogen ion is released, where does it go? Somebody has to accept that hydrogen ion. So this NH2. Now here, keep this in mind that NH2, let's do this here. H2S, so H2S, aqueous means in water medium. Okay, so this is releasing the hydrogen ions, and 2 hydrogen ions are being released, aqueous, and sulfide ions, -2 ions, aqueous. Okay, so that's one piece, because so this is definitely acting as an acid because it's releasing the hydrogen ions. But what's happening in the case of the other guy? Let's look at this one. So for us, this part of the molecule, CH3CH2, is practically like immaterial, of no use. What is important is this nitrogen. Okay, this has 1 hydrogen here and 1 hydrogen here. So, but it has these lone pairs. So this, anything, remember, that gives lone pairs, or electrons is going to act as a base. So this guy has electrons. So this gives electrons. So therefore acts as a base. Okay. Now, whom is it giving electrons? So this is giving electrons to one of the hydrogens. One of the hydrogens, you know, from the one that is released. So basically, you can also make it like this: H, S, and H. So this is one thing, you know. So in this case, the lone pairs are, remember, hydrogen ions is being unfairly treated by sulfur also, although sulfur is not very electronegative yet. That's a polar, it's a little bit polar bond. So this electrons are given to hydrogen and this bond breaks. And when that happens, what do you see? You see that CH3CH2 NH3. Now nitrogen has 3 hydrogen ions and a +1 charge because it gives its lone pair to hydrogen, and HS minus. So it is just like the hydroxide. So same is the case, the HS minus. Okay, so that way, because the one that gives electron acts as a base, and the one that has accepted the electrons acts as the acid. So this accepts electron acts as a base, and I'm going to write down here also that here this is accepting electrons, accepts electrons. Okay, hydrogen has accepted the electrons, and that's, you know, when the bond breaks, then you form this. So this HS is similar to the hydroxide. Okay, so that's the one piece, you know, from a reaction. They were asking you which of the two are going to act as an acid or a base. So here, just, you know, keep this in mind that if whenever you have hydrogen, whichever entity, hydrogen is in front and is not water, will act as an acid. Okay, that makes it easy. Don't start with water because water is amphoteric. Water can be an acid and water can be a base. Next is they're saying write the formula of the conjugate base of the acids. Remember that the acids and bases, you know, the conjugate acid or bases, the difference is of 1 hydrogen ion. So the difference is of 1 hydrogen ion. Okay, so HF, let's do this. HF, when it releases -1 hydrogen ion, it gives you fluoride ion. And what is a fluoride ion? If HF is an acid, so this becomes the conjugate base of HF. Okay, H3, it's always 1 hydrogen ion. So H2PO3 -1. So in this case, -1 hydrogen ion. So -1 hydrogen ion, and that gives you HPO3 -2. Okay, anytime, let me write this down. Any time 1 hydrogen ion is lost, one negative charge, one additional negative charge appears. So additional negative charge appears. Okay, so this becomes, so 1 hydrogen ion is lost. So here you see the 1 hydrogen ion is this one. Similarly here, one of the hydrogens from here is this. So now you're just left with 1 hydrogen ion, but 1 extra negative charge comes. Okay, next is the H2O. So here also, sorry, H2O also, you -1 hydrogen ion. So -1 hydrogen ion, and this gives you what? OH. And anytime 1 hydrogen ion leaves, it leaves 1 negative charge. Okay, so one negative charge appeared. So this 1 hydrogen ion has gone from here, this is here, and then now you have this negative charge. Okay, so next is HSO4. So here also -1 hydrogen ion, and you will have SO4 -2 charge. Remember, 1 hydrogen ion is gone, this one, and then it leaves with 1 additional negative charge. So this is important. Okay. Next is the formula of the conjugate acid for a base. Now you are given a base. So here you're going to add one hydrogen ion is added. So here, because of the, if it's an acid, the difference is of 1 hydrogen ion still. But the thing is that in this case, the hydrogen ion is given. Let me write this down here. Hydrogen ion is given away. And here, in this case, the hydrogen ion is accepted, is taken in. Is taken in. You know, so here still the difference is only 1 hydrogen ion, not more than that. Difference is 1 hydrogen ion. Okay, now, so let's make this here. Now, carbonate -2, you add 1 hydrogen ion. So 1 CO3 -1. So anytime, so once again, anytime 1 hydrogen ion is added, then so additional positive charge appears. So additional, so sometimes it, so additional +1 charge appears, or and depends, you know, on the case, and or 1 negative charge is reduced. Or let's just put this here. Yeah, additional +1 charge appears, and or 1 negative charge is removed, or reduction in the negative charge, rather. Let's put this here properly. Reduction in the negative charge. Okay, and or a reduction in -1 charge. Okay, so this is the rule. So here -2 charge, now we have -1 charge, and a hydrogen ion has been added. Once again here, add 1 hydrogen ion plus 1 hydrogen ion, One hydrogen ion is being added. So here what's happening? This becomes H3PO4. And remember that -1 charge is now nullified by the additional 1 hydrogen ion. All right, next is water. So here add 1 hydrogen ion. Then this becomes the H3O, and here 1 additional positive charge appears. Okay, that's the hydronium ion. Br -1, add 1 hydrogen ion, and this becomes HBr. So that's neutralized, right? So basically, the neutralization of 1 negative charge also occurs to give you a neutral, right? Okay, so that's one piece. Next is identify Bronsted Lowry acid-base pairs. So in a reaction, okay, now in a reaction, which one is an acid and which one is a base? And which one is which are the products? Which acid is producing like the conjugate base, and a base is producing conjugate acid. So first is never start with water. Always keep this in mind, because water is amphoteric. It can act as an acid, it can act as a base, but you can't just start. So we have to start with either, which is kind of obvious. So what is obvious here? What is obvious? The obvious piece is the H2CO3, right? This H2 is in front, hydrogen is in front. That means this guy is an acid. In case you guys don't recognize these, so this is acidic. This is the, so just call it the, this is the Bronsted Lowry acid. Okay, so this is acting as an acid. Now, once you identify, so this is kind of, so this is the obviously OBVIOUS, obvious since hydrogen is in front, therefore this is an acid. Since hydrogen is in front, therefore this is an acid. Okay, and since an acid, so all these are acid-base reactions. So once you identify that, if you know this is an acid, then obviously this will be a base. Okay, this will be a base. Now every acid has a conjugate base, and every base will have a conjugate acid, and the difference is still going to be 1 hydrogen ion. So it's very obvious. H2CO3 and HCO3, these guys are related, right? And then we have water and hydronium ion are related. The difference is of 1 hydrogen ion. So what's happening here? H2CO3 is giving away -1 hydrogen ion. So that is why you have HCO3. And whenever the hydrogen ion leaves, it leaves with a 1 negative charge. So where did this hydrogen ion go? Water has accepted that hydrogen ion that was released by the carbonic acid. And so there it forms H3O plus 1 charge. Okay, so therefore, this is now acting as the conjugate base, and this is the conjugate acid. Always remember that acid, hydrogen is always going to be in front, and hydrogen is like, the conjugate, the base will have the conjugate acid and the more hydrogen ions. And the acid will have a conjugate base with less number of hydrogen ions. Okay, so that's one piece. Next, let's look at the ammonium and water. So same now in this case, which one is acting as an acid and which one is a base? Now here's an interesting part, that ammonium, because ammonium, hydrogen is not in front. There are 4 hydrogens, but they are written at the back. In water, hydrogen is written in front. So here, this is obvious that this, because hydrogen is written in front, therefore water is acting as an acid in this case. Okay, although water is not an acid, but it acts, it's amphoteric. Okay, next, if that is acting as an acid, then ammonium is a base. Now keep this in mind, like nitrogen, because it has got lone pairs, it acts as a base. Okay, now since an acid will have a conjugate base, so obviously the if this is an acid, then the conjugate base, oh wait 1 second, ammonium. Oh, wait 1 second. So I think it's this one. This is an acid. Conjugate base is, this is a base. No, I'm sorry. Little bit messed up here. Sorry about that. Let's go back and like just fix it, because see, this is how, because of it's just a human nature, you know, to start from the more familiar sites. But here, that's what that got me. Okay. Anyways, is it because that's how it's a good thing? Okay. Anyways, good practice. So anyway, so here you see water and you have the hydronium ion. These are like coming from like the same family or same types, ammonium and ammonia. So hydronium ion and water are related. So this is an acid because more hydrogen ions and because hydrogen is in front. Now this is acting, this is not an acid, but this is acting as an acid. Okay, so this is the Bronsted Lowry acid. So minus, so H3O plus 1, right? Minus 1 hydrogen ion. This is giving away 1 hydrogen ion. Obviously, this is acting as an acid. So H2O is the conjugate base of H3O plus 1. So this is the conjugate base. Okay. Next is the, so that's the pairing. Next is the ammonia versus NH3. Okay, NH3. And then you have NH4 plus 1. Okay, so NH3 is acting as a base, So NH4 is the conjugate acid of NH3. Okay, conjugate acid. So conjugate acids, you know, hydrogen can be anywhere in that case, but for other neutral acids, you know, so that's why. So this was a little bit tricky one, but we got it. Okay, so this one, ammonium is acting as a conjugate base of ammonia. So these are the conjugate bases here. Conjugate base, conjugate acid. Okay, so that's the pairing. All right, so this finishes this part. Next, we are going to look at the identification of the stronger and the weaker acids and predicting whether the product or the reactant is formed. Now, for this, you would need the tables that are in your handout for the next questions, okay? But this one, I highly recommend that you do more practice on identifying the Bronsted Lowry acids and bases, base pairing, okay? After that, we will do the next ones, all right? Thank you.